Okay, this is the 2011 Maths Methods Exam 1. I'm going to run you through some work solutions. As always, any questions or comments, or if you find a mistake, just let me know. Okay, here we go. Question 1a. Differentiate the square root of 4 minus x with respect to x. So we'll start with d dx. Simple chain rule question. Take a half out the front, take -1 out the front, -1 being the derivative of 4 minus x, and reduce the power to -1/2. So clean that up and you get -1 over 2 times the square root of 4 minus x. Make sure it's clear that the denominator is all of this. So I'd maybe do this over 2 lines if I was going to do it again, but whatever. Alright, so you'll notice down here I've got a percentage, so that's the percentage of people who got full marks for each question. So fairly good start, 60% of the state got that question right. So moving on, already you see we dropped down to 44. This question was a little bit harder. Let's see, we've got, it's a product rule, so x squared sine of 2x, and we want to find a g dash of pi on 6. So you'll notice I've actually made a mistake here, but if we differentiate it, if we differentiate x squared, leave sine 2x the same, and leave x squared and differentiate sine 2x, you get 2x sine 2x plus x squared times 2 cos, and that should be 2x. So if you're writing this down, change that to 2x. I think the rest is right. So if we sub in pi on 6, we get 2 times pi on 6 sine of pi on 3 plus pi squared on 36 times 2 cos of pi on 3. Sine of pi on 3 is root 3 on 2. Cos of pi on 3 is a half. Make sure you know your exact values. Simplify that a little bit and you get that. Okay. Question 2. Find an antiderivative of 1 on 3x minus 4 with respect to x. Very simple question if you know how to anti-differentiate. Note that it says an antiderivative, so you don't technically need to have the plus c on here. It doesn't hurt to do it though. So the answer is 1 on 3 log of 3x minus 4. Make sure you've got your base here and make sure you've got your modular signs. Moving on, we've got to solve this equation. The easiest way to attack these, I'm sure you've done plenty of examples, is to turn it into a quadratic. So start by taking the 16 over and make it equal to 0. Now 4 to the x is the same thing as 2 to the x squared. So you have 2 to the x squared minus 15 times 2 to the x minus 16. So hopefully you recognize that is just like a quadratic where what some people would write is let 2 to the x equal a or some other pronumeral, which would give you a squared minus 15a minus 16. And then factorize that. I haven't bothered with the pronumeral, I've just factorized it straight away to 2 to the x minus 16, 2 to the x plus 1. So 2 to the x is equal to 16, or 2 to the x is equal to -1, according to the null factor law. This has got no solution. Make sure you actually write that. So x is equal to 4, as 2 to the 4 is equal to 16. How many got that right? 28%. Rubbish. Alright, moving on. Probably the easiest question on the paper. State the range and period of this function. The period is going to be 2 pi on 2, which is 4, and the range is 1 to 7. So if the graph was just this, then the range would be -3 to +3. But as we've been moved up 4, then the bottom becomes 1 and the top becomes 7. Okay. You can definitely expect one of these on any exam, solving a trig equation. So easiest way to start is by writing down what the base angle is. So sine of pi on 6 is equal to 1/2. So we start with pi on 6. So that means that 2x plus pi on 3 is equal to pi on 6 or 5 pi on 6 or 13 pi on 6 and so on if we keep going around the unit circle. So I've just put a ... here. So what you could do then is subtract pi on 3 from each of those solutions, which gives you this, and then divide them all by 2 and see which ones are still inside the domain. So this one is negative, so that's outside our domain of 0 to pi. 3 pi and 12 and 11 pi and 12. So if I had have kept going and found one or two more solutions, then they would have been outside the domain, which is fine, so long as you end up with these two here. Okay, question 4. 75% got this right. I think it's the highest for the whole exam. This function has the rule x squared minus 9. The key here is just to recognize x squared minus 9 as a difference of perfect squares. So rewrite x squared minus 9 as x plus 3, x minus 3. So f of x can be written as that. So then f of g of x, if we sub in x plus 5 in for x, we get, instead of x plus 3, x plus 5 plus 3, and x plus 5 minus 3, which simplifies to x plus 8, x plus 2. So c is 8 and d is equal to 2. And of course, if you had c equals 2 and d equals 8, that would have been correct as well. Okay, this question, however, was done really badly. So state the maximal domain for which the function is defined. I think people got into trouble a lot if they were worried about the rules for composite functions, so the range of that has to be a subset of the domain of that and all of that, and I think some people got it confused with sums and products of functions. But really, all you had to do was just have a look at this function. So the square root of x plus 8, x plus 2, you should know that a square root function, or a square root is only defined, you can't have a negative square root, basically. So long as what's underneath the square root, x plus 8, x plus 2, so long as I sub something in for x and I get a positive number, then the function will be defined. So really, all you have to worry about is figure out when this is going to be bigger than or equal to 0. So when is x plus 8, x plus 2 bigger than 0? So x plus 8, x plus 2 is a quadratic, and if you sketch it, I've just actually drawn it down here, you should be able to see, well, that's positive when x is less than 8 and when x is bigger than negative 2. So the maximal domain for the square root function is that x can be anything between negative infinity to negative 8, that's including negative 8, or it can be anything from negative 2 onwards. So that was your answer. Okay, question 5. You've got a probability distribution function, or PDF. That is defined by this, which is a modulus function. Now, easiest way to go about these is to sketch it. So the modulus of 3 minus x just looks like this. And even if you weren't sure what it looks like, you could have just subbed in 2, subbed in 3, and subbed in 4, and you would have had your graph looking like that. So now, any probability that I want to find is just going to be a matter of finding the area underneath the curve, which is just going to be the area of triangles. So the probability that x is less than 3.5, here's the point 3.5 here. We just want that area there, which is the area of that little triangle there, and that triangle there. Now the area of the big triangle is going to be a half times 1 times 1, and the little one will be a half times a half times a half. It gives you a half plus an eighth equals 5/8. Okay, so the second one, probability that x is less than 2.5, given that x is less than 3.5, will be the probability, the conditional probability formula states it's the probability of both things happening divided by the second thing happening. Now the only way that x can be less than 2.5 and also less than 3.5 is the same as a probability that it's just less than 2.5. So less than 2.5 over less than 3.5, again, less than 2.5 is going to be that area there. I think the easiest way to work out that area there is the whole area there, which is a half, minus that area there, which is 1/8, because it's the same as that area there, which we already found. So a half minus 1/8 is 3/8. So 3/8 divided by 5/8, 5/8 of course comes from here, is 3/5. Okay, so again, much easier to go about this question by looking at the graph and finding the areas of the triangles. I think if you try to anti-differentiate that, you're much more likely to get into trouble. Okay, moving on, question 6, classic simultaneous linear equations question. So here are my two equations. We want to find the value of k for which there are infinite many solutions. Now there's several ways to go about this, and if you haven't seen my method before, maybe jump onto the examiner's report because they've got two more methods there, which might make a bit more sense to you. But if you've done matrices before, basically we set up this matrix here, so the coefficients of each equation, so it gives me k, -3, 4, and k plus 7. Find the determinant, so k times k plus 7 minus -3 times 4, which gives me that quadratic there once I expand. So I want to set that equal to 0. Now if the determinant is equal to 0, then that means that there's either no solutions or an infinite amount of solutions. So I set that equal to 0, factorize and solve. I get k equals -4 or k equals -3. Now for one of these, there's 0 solutions, and for one there's infinite solutions, but I don't know which is which. So I have to sub in -4 and -3 into both equations, and this is what I get when I sub in -4, and this is what I get when I sub in -3. Now this is the one of interest to us, because what you should be able to see is that -4 minus -3 equals -1, and 4x plus 3y equals 1. They're actually the same equation. If you just multiply this one by -1, you get this one. So if k equals -4, the two equations are identical, and therefore there's an infinite amount of solutions. So the answer is k is equal to -4. So moving on to part B. Part B is much easier if you got part A right. Basically, there's a unique solution everywhere else. So when k equals -4, there's infinite solutions. When k equals -3, there's none. So everywhere else, there's a unique solution. So that's why we've written k is an element of R, except for -4 and -3. Make sure you use the right brackets here. Should be these curly ones, which tells me that it's -4 or -3, not in between the two. Alright, make sure you have the right brackets. Okay. Question 7. A biased coin is tossed 3 times. The probability of a head from a toss of the coin is P. Find the probability of getting 3 heads from 3 tosses. Very easy, just P times P times P, which of course is P cubed. With this next one, 2 heads and a tail from 3 tosses. Now you might have used the binomial theorem or something like that for this one. Basically, there's 3 ways it can happen. We could get 2 heads and then a tail, or heads, tails, heads, or tails, heads, heads. So there's 3 different ways that can happen, and the probability of each one of these things would be the same. It would be P times 1 minus P. So really, we could just write it as 3 times P times 1 minus P. Simplify that to 3P squared times 1 minus P. Okay, so moving on. If the probability of obtaining 3 heads equals the probability of obtaining 2 heads and a tail, find P. So we just have to set them equal to each other. The two answers from the first 2 parts of the question, set them equal to each other. So P cubed equals 3P squared 1 minus P. Expand that, take everything over to the left hand side, you get 4P cubed minus 3P squared. Factorize that, you get P squared 4P minus 3. So P is either equal to 0 or 3/4. Now I think what a lot of people did here was they assumed that 0 was wrong because the probability has to be more than 0. That's not necessarily true, so I'd say this is probably pretty controversial at the time, but there's no reason why the probability of getting a head couldn't be 0, but I'd say that was a bit controversial at the time. Anyway, the answer is 0 or 3/4. Okay, question 8, more probability. So now we're looking at 2 events, A and B. Probability of A is 3 on 5, probability B is 1/4. If A prime denotes the complement of A, calculate A prime intersects B when the probability of A union B equals 3/4. Okay, so I'd start with this one. Maybe quickly just draw up a Venn diagram, see what we're looking at here. I'd start by working out the probability of A intersects B, which is going to be the probability of A plus the probability of B minus the probability of A union B. So 3/5 plus 1/4 minus 3 on 4. Put it all over 20 and you end up with 1/10. So 1/10 goes in the middle there. Okay, so the probability of A prime intersect B, we're looking for everything that's not in A and is also in B. So it's this little shaded area in here. Now that shaded area is going to be the probability of B, which is a quarter, minus 1/10. So a quarter minus a tenth is 3/20. So 3/20 is what we're looking for here. Alright, part B, much easier. Find the same probability if A and B are mutually exclusive. Now, mutually exclusive is when there is no intersection. So when the two circles don't overlap, which means that the probability of everything not being in A and being in B is just going to be everything that's in B. So it's a quarter. So there you go, 1/4. Alright, second last question, and it was a massive one. So parts of the graphs of two functions. So we've got x cubed minus ax and a straight line ax, and they intersect when x equals 0 and when x equals m. So what we're asked to do with that information is find if that shaded area is equal to 64, then we have to work out what A and work out what M are. Okay, so I think the easiest way to go about this one to start off with is use the fact that this point here is the intersection of the two functions. So when x cubed minus ax is equal to ax. So I'd start there. So the intersection of f and g is when x cubed minus ax equals ax, and I would solve that. So if we take everything to the left, we get x cubed minus 2ax equals 0. If we factorize, we end up with x is equal to 0, or x is equal to plus or minus the square root of 2a if we solve this bit in here. Now we know that the point we're interested in is this point here. So we know that it's not this intersection where x is 0, and the one down here must be negative root 2a, so m is the square root of 2a. So now we can just work with that, and we don't have to worry about the m until the end. Okay, so now using the area between two curves formula, we can integrate. So what we're interested in is the area from 0 to the square root of 2a. Now the line that was on top is ax, and the line that's on bottom is x cubed minus ax. So the equation, or the integral to find the area between the two curves, is that one there. So that's what we're trying to solve. Okay, and we know that that's equal to 64. So we're going to set that equal to 64, and we're going to attempt to solve for a. Okay. Now, if we clean this up a little bit, we get negative x cubed plus 2ax. If we anti-differentiate, we get negative 1/4 x to the 4 plus ax squared. If we sub in root 2a, now the square root of 2a to the power of 4 is 2a squared, and the square root of 2a squared is 2a. So we end up with this. Now 2a all squared is 4a squared. So we end up with negative 1/4 4a squared plus 2a squared. Those 4's will cancel, and we just end up with this. Negative a squared plus 2, there should be a squared there, sorry, 2a squared. So that leaves me with a squared equals 64. So a is equal to plus or minus 8. And again, because we know that a is bigger than 0, as it has to be, and we're told up here, then that means that a has to be 8. Now, what I've done is I've forgotten to finish off the question. That's awkward. We need to work out what m is as well. So we know that m is equal to the square root of 2a. So if I sub 8 into here, I get 16. So m is equal to the square root of 16, which is 4. So I've made 2 mistakes in this question. So if you're copying it down, there should be, where was it? There should be a squared here, and we need to finish off the question and sub 8 into the square root of 2a, and write that m is equal to 4. So that was worth 4 marks. I think I probably would have gotten 2 if I was lucky. So I wouldn't have been one of the 16%. How annoying. Alright, so the final question, question 10. We have a wireframe where ABCE is a convex quadrilateral. If you don't know what a convex quadrilateral is, who cares? The point D is on line segment EC with ABEDs 2. So these two are 2 centimeters. This is A, and these angles here are all pi on 2 or 90 degrees. We're also told that this angle here can be anywhere between 0 and pi on 2, not including 0 or pi on 2. Alright, so it starts off fairly easy. We want to find BD and CD in terms of A and theta, and that was really just using SOHCAHTOA, which you would have learned in year 9. So BD we can do using the fact that cos theta is equal to BD over A, so BD is equal to A times cos theta, and in a similar way we can do that CD is equal to A sine theta. Okay, so moving on, find the length of the wire in the frame, including length of BD in terms of A and theta. So basically add up the lengths of all of those bits of wire. So 2 plus A plus A cos theta plus A cos theta plus A sine theta gives you this. 4 plus A plus 2A cos theta plus A sine theta. Okay, then it gets hard. C. Find DL d theta and hence show that DL d theta equals 0 when BD equals 2CD. Alright, so we'll start by differentiating. So if I differentiate L, the 4 will disappear, the A will disappear, 2A cos theta will become negative 2A sine theta, and A sine theta will become A cos theta. Okay, so there you have your differentiated function. Now we're told that BD is equal to 2CD. So if BD equals 2CD, BD is A cos theta. So that if BD is 2CD, then A cos theta is equal to 2 times A sine theta, which is what I've written here. So A cos theta equals 2A sine theta. So if I sub that in to here, instead of A cos theta, I'm going to write 2A sine theta. So DL d theta is negative 2A sine theta plus 2A sine theta, which is 0, which is what we wanted. So we've shown that DL d theta is equal to 0 if BD is equal to 2CD. Okay, now the last question, which 5% of people in the state managed to get it. Find the maximum value of L if A is equal to 3 root 5. Now again, if you go on the examiner's report, there are a few ways to go about this. So I picked the one that I think is the easiest. Basically, I would imagine where most people went wrong here was thinking that the maximum is when DL d theta equals 0, so they would have differentiated the function, set it equal to 0, and then been not sure what to do. But the key was that we were told that DL d theta is equal to 0 when BD equals 2CD. So they've told you, well, the maximum, if DL d theta equals 0, that's going to be where the maximum is. So, but that happens when BD is equal to 2CD. So we don't actually really have to worry about the derivative. We've been told that BD is equal to 2CD. So here's the triangle from the diagram up here. This is 3 root 5, and this length here, well, this length here is double this length here. So we can actually just set up and because it's a right angle triangle, I'll just let that equal x, and that can be 2x, and that's 3 root 5. So I can just use Pythagoras to work out what x is. So if I use a bit of Pythagoras, 3 root 5 squared equals x squared plus 2x squared. 2x squared is 4x squared, so you put them together, you get 5x squared. 45 divided by 5 is 9, so x is plus or minus 3. Now obviously it's a positive length, so x is equal to 3. So if x is 3 and BD is 6, then I can work out what the length is. It's going to be 4 plus 6 plus 6 plus 3 plus, what was it, 3 root 5? So put those all together, 4 plus 3 root 5 plus 2 times 6 plus 3, 19 plus 3 root 5. And that's the answer. So that was pretty tricky, but what you actually had to do wasn't that bad. I think it was a bit harsh was the fact that it was only worth 1 mark. I'd say that's because it was quite hard and they didn't want to penalise people too much. Anyway, that's the end of the paper. So that's probably the last exam 1 I'll do for a little while. I might look at some multi-choice questions next. Thanks to everyone who has subscribed. We're over 100 now, so keep asking questions and check back. Hopefully I'll have some more videos up soon, and good luck with the studying.